everyone, welcome back to Math 56. In this video, I will teach every single exponent and power identity. Let's get started. So a to the m times a to the n equals a to the m plus n. So in other words, if the bases are the same of both the exponents, you can just add the exponents if they're in multiplication form. For example, if I have 2 to the 5 times 2 to the 3, I can just add up the exponents as the bases are 2. So I get 256 after 2 to the 8. Now, anything to the 0 is 1. Now, like 3 to the 0 is 1, 4 to the 0 is 1, negative 9 to the 0 is 1. But just be careful, teachers use this trick. So, you have a minus outside a bracket, and in the bracket, you have a 5 to the 0. So, that's minus 1 because, as you know, BODMAS. So, exponents are higher than multiplication. So a to the 0 times a to the n is a to the n, and I'm telling you, some of these rules aren't really useful in our lives, but math teachers typically ask these in the papers, which is very surprising, I would say. Anyways, so for example, 5 to the 0 and 5 to the 3, so 5 to the 0 is 1, so this basically is 5 to the 3, so it's 125. So now a to the m to the n is equal to a to the m times n. So in other words, if you have a power raised to another power, you can just multiply those two powers and raise it overall to the base. So for example, if I take negative 2 to the 5 brackets and that's raised to the 2, I can get negative 2 times 5 times 2 because they're exponents and the 1 is over top, 1 is exponented to an exponent. So you get 2 to the, negative 2 to the 10, which is 1024. Now I've just removed the minus because our exponent is even, so any negative number multiplied by itself of even number of times is always even. So this is also very important rule. So a to the negative n is equal to 1 over a to the n. So let's give an example. So 5 to the negative 2. So that's equal to 1 to the 5 squared because if you look at that rule carefully, that's how it is. So that's 1 over 25. This is a very important rule. Now a to the m to the nth root is equal to a to the nth root exponented to m. So for example, because I know this doesn't really make sense, you can get so if I'm keeping n as 2 just for simplicity's sake, so 4 to the 4 to the second root or the square root is equal to the square root of 4 to the fourth. So that means the square root of 4 is 2, so you get 2 to the 4, which is 16. So rather than just having to do 4 to the 4 in the beginning, we can simplify it like this: a to the nth root times b to the nth root is equal to a multiplied by b to the nth root. So let me just show you an example. So for example, the cube root of 16 times the cube root of 81. So you can make that the cube root of 16 times 81, which is the cube root of 1296. Okay, so let's go ahead. A to the mp to the to the to the npth root is equal to the a to the m to the nth root. So now for example, if I take the sixth root of 4096, I can make that because there's a common, I can make that the sixth root of 2 to the 12. And now there's a common factor of 6, which is p in this case. So I get 6 to the 1, so I get 2 to the 2 times 6 to the root of 6 times 1 now, because p is 6, we can just strike that, so then we get 2 squared, which is 4. Now a to the m divided by a to the n is equal to a to the m minus n. Now this is one of the most crucial rules you're ever going to learn, so pay attention carefully. So I take 7 to the 10 over 7 to the 7. If I do this by doing the 7 to the 10 and 7 to the 7, I don't think you're even going to finish your exam paper. So you can use the quotient rule. This is called the quotient rule. So if you plug in our values, you get 7 to the 10 minus 7, which is 7 to the third, which is 343. Like if you just did 7 to the 10 directly, you'll get some 9-digit number. And if you do 7 to the 7, you'll get some 6-digit number. And I'm sure nobody wants such large numbers. Anyways. So ab to the m to the whole m is equal to a to the m times b to the m. Now, for example, if I take the square root of 8 times the square root of 6, the whole squared, so then I can get square root of 8 squared times the square root of 6 squared, which is 8 times 6, which is 48. So now if I take the nth root of a and the n divided by the nth root of b, I can get the nth root of ab. So to understand this, I'll just give you a value. For example, if I take the sixth root of 8192 and over the sixth root of 2, if I do this with regular arithmetic, this is not going to work. So if I use my the formula above, I can get the sixth root of 8192 over 2, which is the sixth root of 4096, which is 4. Now if I take the nth root of the mth root of a, which is like a mass 2 square roots, I can get to the a to the mnth root. So just to give you an example, so for example, if I have the fifth root of the second of the square root of 1024, I can combine the square roots. So I have 5 on the outside and 2 on the inside. So I can make that the 10th root of 1024, which is 2. So we're almost done, guys. Just last one. This is the most crucial one you'll ever see, and this is the most useful one. Now, a to the m over n equals to the a to the m to the nth root. So, to just give you an example, 64 to the 2 by 3 is our example now. So that will become the cube root of 64 squared. Now using one of our older rules, which was the nth root of a to the m is equal to the nth root of a to the m. So that becomes the cube root of 64 squared, which is 4 squared, which is 16. Okay, now I'm going to teach you my secret method to remember all these formulas. So basically, if you have an exponent to the exponent, you just multiply the exponents. Now if you have to multiply two exponents, you just add the exponents. That was in our rules, right? So whenever you just bring it one step lower, so from exponentation, which is tetration, which I will not be talking about in this video, from exponentation of an exponent, you just multiply the exponents, and you multiply exponents, just add them. So that's my secret method. Anyway, so thank you guys. Thank you for watching. See you in another video. Bye.